Hello everyone, my name is Frederick and I'm with ICPC Analytics and I'm here to present problem L, swap space. So in this problem you have been given the great responsibility of running a data center. In your data center you have a large number of computers with associated hard drives. Unfortunately you have not thought your capacity well enough in advance, so you need to upgrade the capacity of your data center. So what you're given is the number of hard drives, which is less than 10 to the power of 6. And for each of the hard drives, you know the current size and the new size. And all of these sizes are less than 10 to the power of 9. Because of course, 1,000 petabytes should be enough for everyone, right? So what you then are given is a list for each hard drive, you know the current size. So for the first drive, it's currently 7 gigabytes, and you need to reformat it into a 5 gigabyte drive. So it can actually be reduced as well. In the second case, it's from a 2 gigabyte to a 2 gigabyte, so there is no change there. The third drive is currently 1 gigabyte and will be updated to a 2 gigabyte drive. So what we can see here is that some of these are decreasing. So we have this one is decreasing, this is plus minus 0, this one is increasing, this one is increasing, and that one is decreasing. So what we then can do is to divide these into two separate sets and treat them independently. So we have the increasing ones, we sort them in increasing order. So we have 1, 2, and 3. And they have the new sizes like that, and then we sort the decreasing drives in from the largest to the smallest. And now we need to figure out how much extra swap space do we need in order to be able to swap out the content of the current drive and then be able to reformat it and then reload it again. So what we now will do is to go through this list in this order and maintain how much swap drive do we currently need and how much extra space do we currently have. So I will move over to the other side now. So we say swap and extra. So in order to be able to swap out the first drive, we need to have 1 gigabyte of swap space. We then reformat the first drive and load the 2 gigabytes into it. We now have 1 gigabyte of extra space. We now come to the second drive. We need 2 gigabytes of space, and since we have 1 on the swap and 1 extra, we are fine. So we can swap that out, reformat it, and replace it. So after the second step, we still have 1 swap and 1 extra. The third step, now we actually need 3 gigabytes to swap that out. So we need to increase the swap space with 1. And after swapping that out and replacing it, we now get 3 more gigabytes there. So now we have 4 gigabytes of extra space. So an argument here that why you can do this greedy sorting is that if you had taken a larger drive first, you might actually use more swap space than necessary because you haven't added extra space. And the argument for why you can take the largest drive first here is because at this point is when you have the most extra space available. So from this point on, the extra space will just decrease. So now we see that in order to fit the 7 gigabytes, we need actually 1 more megabyte of swap. And then we replace it, so we reduce the extra space with 2. And now we need 5, and since we have exactly 5 gigabytes extra, we're fine. And now we have to reduce the space with 1. So in the end, we need 3 gigabytes of extra space, which is our answer. So this is a relatively easy problem. The challenge is to be able to convince yourself that this greedy solution actually works. And if you do that, the rest is relatively straightforward. And since we need to sort the numbers, the total time complexity of the problem will be order n log n. And since we have 10 to the power 6, this should fit within the time limit, which is actually quite high, namely 6 seconds. So, thank you very much and good luck.